SQL injection. As the name suggests, in this technique the hacker injects specially crafted SQL statements to exploit improper input sanitization on the back end of a website. SQL is responsible for performing operations on a database like inserting values, updating values, and deleting values from a database table. Most of the times, SQL deals with the data that is given by the user. For example, if you consider a login page, the user gives his username and password to log in. These username and password values must be validated by the server. Intuitively, the way it's done is by performing an SQL query like this, which tries to fetch a row from the user's login table with the given username and the password values. If the query returns a row, then the credentials are valid. Else, they are not. These SQL queries, as you can see, include user input. The user can simply provide an SQL statement like this as the input for the username field. And when it's sent to the server, it modifies the hard-coded SQL query on the backend such that the query always returns a row no matter what the password is. This is a typical example of SQL injection. To prevent these attacks, the user input must be first sanitized before performing any SQL operations. Cross-site scripting. This loophole also exists because of the improper input sanitization. In this attack, the hacker injects some malicious script on the client side, or in other words, the browser. But how does injecting a script on the browser affect the whole website? It's simple. When the hacker injects some JavaScript, let's say, in a web page and save the activity on the web page, the user input, which includes the malicious JavaScript, is sent to the server so that it can be saved on the database. If the server doesn't validate the user input and blindly saves it into the database, it means that any user who requests the same web page is also served with the script that the hacker injected. And the user's browser executes that script because it is coming from a website that they trust. By doing so, the hacker can steal the cookies of a user, can deface a website, and can do a lot of other damage too. For example, let's say this cross-site scripting vulnerability exists on a web page where users can post comments and see others' comments. The hacker can inject a JavaScript like this as a comment, which sends the cookies of a user to the hacker's server. Whenever any user is visiting this web page, the script is automatically executed by their browser, and their cookies are compromised, which can lead to account takeover. Insecure deserializing. Serializing is the process of converting some data from one form to another, so that both the sender and the receiver will know how to handle it. When the web server sends some kind of data to the browser, it first serializes it. And in the same way, when the browser sends some serialized data to the web server needs to deserialize the received data. If no proper checks are done by the server before deserializing data that is received from the browser, it can lead to a serious vulnerability like remote code execution or privilege escalation, etc. For example, consider that a website is using Pickle library in Python to serialize and deserialize data. The server serializes some data and writes them into cookies. The cookies are then sent to the browser. Now a hacker can take advantage of this by replacing the cookies with a serialized Python object, which looks like this. When this object is serialized with some Pickle library and sent to the server in the form of a cookie, the server needs to first deserialize the cookie in order to understand it. If the deserialization is done without proper checks, this leads to the creation of the Python object that the hacker specially crafted, and this further leads to the code being executed on the web server. The hacker will now be able to browse through the file system of the server, access the files, and do much more by getting a reverse shell from the web server. This loophole can also be fixed by properly sanitizing everything that comes from the browser before handling it on the server. Cross-site request forgery. In this loophole, the hacker sends forged requests to a website from a different website. This different website is often the website hosted by the hacker himself. For example, let's consider a web page like this that gives the user an option to change his or her password. When the user types in the new password and clicks change, a post request is sent to this URL with the new password as a parameter. The web server then changes the password of that particular user. Now, a hacker can create a web page that automatically sends a post request to the same URL on the website, but with a hard-coded password of his choice. He then hosts this web page on his server and simply sends the link to the victim. When the victim clicks on it, the post request is sent automatically to the target website. Since the victim is already authenticated on the target website, the password is successfully changed to the one that the hacker wanted. This can be prevented by implementing CSRF tokens. Improper security configuration. Websites are developed by developers. Developers are humans, and humans make mistakes. These mistakes may include improper configuration of the web server. For example, when a website is hosted, the developers may completely forget to change the default passwords of the server's admin console, or to completely uninstall the server's admin console. In such a case, a hacker can completely take over the website by using a default password like admin or password or root to just log into the server's admin console. This might sound silly, but even companies like Google faced such issues in the past. So always remember to change the default passwords. Thanks for watching this video. Hope you liked it, and if you did like it, please don't forget to leave a thumbs up below. If you did not subscribe yet, please hit the subscribe button and also turn on the bell icon to get instant updates from my channel. Once again, thanks for watching. I'll meet you in the next video. Cheers.